Alright, so I'm going to go ahead and do part of homework 5 with you just to kind of get you started. So this is from a continuation from last week. So we're still going to do complex numbers. You're going to go ahead and simplify the expressions, and you're also going to make sure to name the sets. So I'll do some of the naming with you. So let's take a look at number 3 and 4. You guys will do 1 and 2. So for 3 and 4, remember, you look at what's between the parentheses because there's a minus here. That means that you technically are distributing by a -1 here and a +1 because there's no negative on the front. This is going to change to -3 plus 8i, so no change there. However, the other one does change to -1 minus 8i. You're going to go ahead and combine like terms. Remember that you have to kind of see, okay, what can I put together? So I'm going to be left with -3, -1, 8i, -8i. So those cancel, so your final answer here is -4. Remember that your answer needs to be in the form of a plus bi. In this case, the -4 is your a, so you're done. Then you're going to have to name them. So that was when we had our whole chart here with the complex number, pure, imaginary, and then you had that thing that was going on. So you might have to take out those notes for this homework. So for this one, -4, remember, it's no matter what example I give you, it's going to be complex. So we know that it's complex. -4, if you're looking at your chart in front of you, there are two options. It's either pure imaginary or real. So now this one is real. And then you have two other options. It's either irrational or rational. Okay, this one we're gonna have our rational, and then from there it's asking us, okay, is it an integer? Which this is an integer, because integers are allowed to be negative numbers. And then from there they're gonna ask you, I can't remember which one's next. I believe it's a whole number, but it's a -4, which means that after integer, that's it. There's nothing else that can be named for -4. It's not a whole number. It's not a natural number because you're not allowed to be negative. So you're gonna have to name all of these sets. Let's look at number 4. Now look at this parentheses. Notice how the -5i, there's no sign in between here. So when that happens, that means you're multiplying. So like on the number 1 and number 2, you're not multiplying these because you're kind of distributing a +1 here and a 1 here. On this one, same thing, +1 and -1 distributed. But here, there's actually a distribution, so you're going to multiply them. You're going to get 10i plus 5i squared. So far that's what I have. But remember, you guys have to remember I squared is equal to -1. So I technically have 10i plus 5 times -1. So 10i minus 5, but it has to be in the form of a plus bi. So it's -5 plus 10i. Now, if you look at your chart, remember, anytime it's in this form here, it's complex. So I know that it's also complex. However, this is not, it's either real or imaginary. This is not imaginary, okay? The only way it would be imaginary is if 10i was your answer. But because you have a real number attached to it, it cannot be pure imaginary. It's only under complex. Okay? So you have your two answers here. So C for complex. You guys are going to do number 1 and 2. And then I gave you the names for these two. Your final answer should be these. Make sure you show your work. And you should end up with complex as your final name for the set. Now, I'm not going to give you the names of all of these. I do give you the answer of what your answer is supposed to look like, but you guys have to use your vocabulary chart that I gave you guys to kind of determine, okay, what's what. Now, let's take a look at number 5. 5 through 8, they're fairly easy. Remember that you look at the parentheses, you see how there's nothing there? That means that you're going to be distributing. So you're going to be multiplying or foiling, whatever you want to call it. So you're going to do 7 times 4, 7 times 3i, I times 4, and I times 3i. That's basically what you're doing there. I'm actually going to go ahead and skip and go on to 6, help you do that one, and then 7. You guys will do 5 and 8. So I'm going to go ahead and FOIL this. So I'm going to be left with -3, positive 6i, -8i, positive 16i squared. Now again, remember I squared is equal to -1. So anytime that you see that, you're going to have to just replace it. I'm going to combine my like terms. I'm going to be left with negative 3 minus 2i plus 16 times negative 1, because remember it's that negative here. I'm going to keep going. Negative 3 minus 2i minus 16. I can still combine negative 16 and negative 3. I'm going to be left with negative 19 minus 2i. Remember that it always has to be in the form of a plus bi. And then that's what we get. So negative 19 minus 2i. And there's your answer. Okay, you guys will do 5. I'm going to help you get started on 7. Only because I just want to clarify that whenever you have negative 7 plus I squared, remember that that's just telling you that you have that 2 times. And then you're going to FOIL that. Okay, so you're going to multiply all of that. But now let's look at 8. I just want to kind of remind you guys, see how this is 3 plus 5i, and then again you have 3 minus 5i. That's that conjugate that we learned last time. It's when you have a plus bi times a minus bi, so it's the same numbers. Your answer has to be a real number. Okay, so that means you should have no i's. Okay, so no i's when you're doing this here. Okay, so keeping that in mind, let's go ahead and solve this one. So I'm going to go ahead and FOIL. So I'm left with 9 minus 15i plus 15i minus 25i squared. Now notice how right here we have a whole bunch of i's going on, but they told us, or based on the conjugate, we know that your answer has to be a real solution, meaning there should be no imaginary numbers. So right now it looks like there's a lot of imaginary numbers going on here, which means that if they don't cancel out or get rid of, or you don't get rid of them at some point, that means you are doing this wrong. Okay, so now notice how these 15s cancel. We're good there. Now the I squared, remember that's negative 1, so 9 minus 25 times the negative 1. Now negative 25 times the negative 1 is a positive 25. And if you go ahead and add these, we're going to end up with 34. Now 34 is a real number, and there is no i's left there. Okay, so we know that we've done this correctly. And then you're going to have to name this. All right, so remember, we always know we start off with complex. Is it real or imaginary? This one has to be real. Now you guys keep going. Okay, so fill those in. All right, again, I did not give you the answer, but there's more for this 34. It doesn't stop at real, so look at your vocab. Like I said, I am not giving you the answers to the names because I really need you guys to use your vocab. Okay. All right. I will do number 9 and 12. These are, if you're not sure how to do these, you're going to have to use your notes from last week. Look at the conjugate part on the back of the complex number notes. So number 9, I'll help you get started on that one because that one has a lot going on. So first things first, look at your parentheses. There's nothing there. That means you're going to have to multiply this whole thing that you see here. Okay, so you guys are going to FOIL that out. Okay, so you're going to do this part. Combine like terms, do all of that stuff. So let's go ahead and so we're going to get 10 plus 35i minus 4i minus 14i squared. So that's what I have so far. Okay, I'm going to combine my like terms right now, just so I can clean this up a little bit more. I'm going to be left with 31i, and then minus 14 times that negative 1. Remember, I squared. So now that's going to give you a positive 14. And then I'm going to combine like terms. This is going to be 24 plus 31i. But you still have to do this part here, and I'll do it in a different color. So now I'm going to do this off to the side. Remember that is 3i squared. So that's going to be 3 squared and I squared. So I'm going to be left with 2i, negative 2i. And this is basically what you're doing here is 3 squared and then I squared. That's what you're doing here. So I'm going to be left with negative 2i times 9 times negative 1. So now negative 2 times 9 is negative 18. But negative 18 times a negative 1 is positive 18. And then you still have that 1i. So now because that's a positive 18i, that's why I'm rewriting it like this. We can now combine these two. So your final answer in the form of a plus bi is going to be 24 plus, we're going to be left with 49i. And now you're going to tell me what is the name. What would you call this? Okay, I'll do this one with you. So again, it's always complex, so that can always be something you write down, complex. Now, is this real or imaginary? It's actually just complex, because remember I told you the moment you have an A attached to the BI, you cannot be purely imaginary. Now, let's pretend that this was only 49i, then this would also be imaginary, but in this case it's not. Okay, so then that's part of your answer. 24 plus 49i. Let me just double check it, that's what I had as the key. Yep, 24 plus 49i. Alright, let's look at number 12. So now this is where you look at if it's a monomial or a binomial, because you're going to have to multiply it either by I or by the conjugate. So if we look at number 12, look at the denominator being down. So the 2i here, this is a monomial, which means that whenever the bottom is just one term, you're going to multiply the top and the bottom by just the letter I. Okay, so I'm going to multiply everything by I. I'm going to be left with 8i plus 4i squared over 2i squared. But again, remember that I squared means negative 1. Now, you cannot combine these two because it's like combining x and x squared. You can't do that. So now from here, the I squared, that is a negative 1. So I'm going to rewrite that. So 8i plus 4 times that negative 1, and then 2 times that negative 1, because I have an I squared. So now let's clean this up. I get negative 4, but I'm going to write it in the form of a plus bi, okay, because that's important. So I'm going to write negative 4 plus 8i, and then I'm going to put it over negative 2. Now, this is where you're going to have to split it up, okay? So I'm going to split it because it's easier for me to see. Alright, so then this is going to end up, these cancel out to just a 2, and then these cancel out to a 4, and then you have to give me the name. Oops. And again, I am giving you the answers. Oops, sorry. That was a negative 4. I think I forgot my sign when I switched it. It was, I think this is what it was before. Sorry about that. Negative, and then I think this was a positive 8i. Yeah. So then this would cancel to negative 2, and then this would cancel to negative 4i. Or sorry, positive. I don't know what I'm thinking. That would cancel out to a positive 2, because negative divided by negative is positive, and then 8i divided by negative 2 would be a negative. So that's how we get this answer. Again, you're going to have to tell me the name of it. So earlier I just forgot about this negative, and that's how I got a plus 4i. So that was my bad. Alright. So let's look at these. Okay, so again, number 13, remember when it's just one term, your monomial, you're going to multiply the top and bottom by just I. Okay, the whole thing. Alright, so you guys will do that. Let's take a look at number 16. Now, when the bottom is, actually I'll do 14, no, I'll do 15 and 16. I'll help you out with 15, and then I'll do 16. Alright, so remember that when you have two terms, so these right here, these are binomials, two terms at the bottom, that means you're going to have to multiply by the conjugate. So, for instance, 1 minus I, the conjugate of that would be 1 plus I, okay? So you're going to multiply top and bottom by the conjugate. Number 15, same thing, you're going to multiply by 3 minus I, because you're doing the conjugate. And then number 16, it's going to be the conjugate again. It's going to be negative 1 still. That does not change. The plus 4i is what changes. Okay. Alright. So now, let's look at number 15. Now, remember what I said? Whenever you're left with a the same thing at the, that you're multiplying the same thing, but one's a positive, one's a negative. The 3 plus I, 3 minus I, that means I better be left with a real number here. Your I should completely cancel. If they don't, you're doing something wrong. Same for the 14 at the denominator and 16 the denominator. So now let's do the top first. I'm left with 12 minus I plus 30I. Here, I ran out of room. Let me rewrite it. So 12 and then minus 4I plus 30I minus 10I squared. And then 9 minus 3I plus 3I minus I squared. Now remember, these are canceling. That's a good sign because my answer needs to be a real number. And this is going to be a negative 1. So that's a negative times a negative 1. I'm going to clean up the top as well. So I'm left with 12 plus 26I minus 10 times a negative 1. And then at the bottom, 9 minus that negative 1, which is just going to be positive if you multiply them, or if you just kind of see it as addition, it's the same thing. So this will be, that's a positive 10 now. So 22 plus 26I. That's because these two turn positive, and then you add them. And then that would be 10 here. So we're going to go ahead and I'm going to split it up so that it's easier for me to kind of see. So this, we're going to divide it by 2. So we're left with 11 over 5. And then we can divide the other one by 2 as well. Plus 13I over 5. Now because these two are the same denominator, you can actually rewrite it and put them back together. And then you're going to name it for me. So 11 plus 3I. Or did I say 3 or 13? I think it was 13. Alright. Alright, let's look at 16. And if I said 3 accidentally, I hope I wrote 13. Alright, so for 16, I know I said I was going to do 16 and then let you do 15. Or help you with 15. But I'm actually going to have you guys do 16. I'll help you start it though. So you're going to multiply it by the conjugate. Okay. I'll help you up until where it's cleaned up. So now from here I'm left with negative 5 plus 20I plus 8I minus, we have 32I squared. Then we have a positive 1 minus 4I plus 4I minus 16I squared. Okay, so I'll help you clean it up. Combine your like terms. And remember that this is a negative 1 here. So we're left with positive 28I minus 32 times that negative 1. These are canceling, and again you have a negative 1. So 1 minus 16 times the negative 1. You guys keep going. Okay. And then make sure you're naming them as well. Alright, so now 17 through 22, they're asking you to write an example of each property using the complex numbers. So for 17, commutative property of multiplication. If you're not sure what that looks like, this is my example. But remember that commutative property is when we're multiplying two things in a different order. So like if this was A times B versus B times A, you still get the same answer. That's what they're trying to say. So you have to use complex numbers. Complex meaning that you have the whole A plus BI in some form. Now the 6 is a complex number, but it doesn't look like that. Get some I's in your examples. Now give me an example of the distributive property. Okay, now for number 19, it says name the additive inverse of 5 plus I. So what is the additive inverse? Again, you're going to have to look at your vocab to kind of figure out what is that number that will help you prove that this is the additive inverse of 5 plus I. 20, same thing, name the multiplicative identity of negative 12. So if you look at your identity for your vocab, we had the multiplicative identity of negative 12, which states that for negative 12I, what identity will give you negative 12I? And if you look at your notes, it actually tells you that if you multiply this by 1, this will always be negative 12I. So this 1 here is your answer. That's the identity that will always help negative 12I be negative 12I. Same with the additive inverse. What will always make 5 plus, what identity or, that they give you will always generate the inverse of, the 5 plus I. So you guys will do those two. And then number 21 and 22, you're just going to have to copy because we're not in school and this comes with like a whole bunch of stuff that I have to explain. I'll explain it, but just copy it down. So what they're saying for 21 is saying the set of complex numbers is closed in the subtraction. True. So they're telling you that if you have complex numbers, you're allowed to subtract them. That's what it means, that it's closed. Now 22, it says the set of irrational numbers is closed under multiplication. So that means that if you have a set of irrational numbers, remember an irrational number is a number that cannot be written as a fraction. So the square root of 6, that is an irrational number because I cannot write that as a fraction. So they're saying that the set of irrational numbers, this is a set. I could have chosen something else other than 6. It says is closed under multiplication. So if I were to multiply these two, they're telling me that I will always end up with an irrational number. But if you look at this, square root of 6 times square root of 6 is the square root of 36, and the square root of 36 is exactly 6. And if you look at your vocab, 6 is actually a rational number, which will then prove this false. It's not always irrational. Okay? All right, so go ahead and finish those up. Finish this homework. I'll do the next one.